Hello maths fans. We're going to be looking at area of parallelogram, and for this we need a little bit of prior knowledge. So first of all we need to make sure that we know how to find the area of a rectangle and the perimeter of a rectangle. Well, for perimeter that means round the outside. So in this case we would do 10 plus 4 plus 10, because this is going to be 10 as well, plus 4. 10 plus 4 plus 10 plus 4 is 28 centimetres. And that is a length. It's not centimetres squared for an area, it's just a length. The area for a rectangle is length times width, or base times height, which is 10 times 4. And in this case that gives us 40, and they are centimetres squared for an area. So, very simple. Rectangles, we do length times width, or base times height, whichever you prefer. Moving on then. A little bit of other prior knowledge we need to know. We need to know what parallel lines are, because a parallelogram is made up of these parallel lines. So they're two lines that go in the same direction and will never meet. Parallel lines. We also need to know the opposite of that, perpendicular lines. Now, perpendicular lines are lines that cross and make a right angle, or make 4 right angles actually. So if they cross at right angles, we say they are perpendicular. If they go in the same direction, we say they are parallel. So a bit of language that we need for this topic. So here's some parallelograms. Now what makes a parallelogram a parallelogram? Well, a parallelogram is a quadrilateral, and a quadrilateral is a 4-sided shape. Simple as that. Any shape with 4 sides we call a quadrilateral. And parallelograms are ones where there are 2 pairs of parallel sides. So we've got this pair of parallel sides here, and they're indicated with a single arrow each to show that they're parallel. And then we've also got a second pair of parallel sides here. And because they are not going in the same direction as the red lines, we indicate them there with 2 arrows. So 2 pairs of parallel sides, that's what makes a parallelogram. Another little bit of information to know is that the opposite sides, so this side and this side, will be the same length. So if I know that length, I also know that length. And the same over here, this side will be the same length as this side. Then another piece of information is that this angle will be the same as this angle. They're going to be equal. So we'll colour those in green. And also, we find out that these 2 angles are equal. So that angle is the same as that angle. So loads of useful information with a parallelogram. Anyway, we're looking at finding the area of a parallelogram. So, one other thing is there's a special case parallelogram when all the sides are the same. We actually call it a special type of parallelogram, a rhombus. Okay, that is a parallelogram where all the sides are the same length. Okay. Anyway, on to finding the area of a parallelogram. So here I have a parallelogram and we've got some measurements, but we don't need all of these measurements. So while there's a few things I could do here, perhaps if you know how to calculate the area of a triangle, you might think, well, if I chop that off, and I chop that off, does that help? Can I work out those areas of the triangles? Maybe, but actually we don't need to do that. What we can do is we can separate a triangle on the end there, and now imagine me picking that up, don't have to imagine, you can watch, and taking it to the other end. You can see I've still got the same total area, so that area of that parallelogram is going to be the same as this, because all I've done is just moved it over there. Haven't changed the area. And that shape there is a rectangle. And that area there is going to be 10 times 3, because it's a rectangle, base times height. So I know that for that parallelogram, the area is 10 times 3. This 4 over here, the slanted height, we don't actually need that. To calculate the area, this slanted length is not useful. What we need are the two lengths that are, and it's a special word we've just learned, or just remembered, perpendicular. We're going to multiply the perpendicular lengths, 10 times 3. So the area of parallelogram, this is the formula that you need. It is the base, in this case 10 centimeters, multiplied by the perpendicular height, in this case 3 centimeters. So 10 times 3, and my area here will be 30 centimeters squared. It's an area, centimeters squared there. And that's it. It's very, very simple, as long as you remember to multiply the perpendicular lengths and ignore the slanty length. Okay, find the right angle lengths, multiply them together, and that's it. Sometimes this formula is simplified to just base times height, but as long as you know that that height is the perpendicular height. Okay, let's look at an example, another example. So here we have some lengths. Maybe pause the video, have a try of this one, and see what you get. And here is the answer. The perpendicular lengths is the 4 and the 6. So we are going to do 4 multiplied by 6, 24 meters squared. That slanty length 7, not useful for the area. It is useful for perimeter, but we're just looking at area. So 4 times 6, 24, that's it. Alright, now here's 3 for you to try, so pause the video, have a go at these, and then I'll show you the answers. Pause the video now. Alright, and here's your answers. So the first one, the perpendicular lengths 5 and 2, 5 times 2 is 10. The second one, the perpendicular lengths 8 and 4, 8 times 4 is 32. And the last one, the perpendicular lengths are 15 and 12, and so it is 12 times 5 is 180 meters squared. Just remember your units. And that's it. Base times height. That's all there is for parallelogram. Base times height. Good on.